cool. Does it tell me? Oh, all right, we'll just go with this. Okay, the first one here is the distance formula itself. Okay, the distance formula is one of our key vocab words, so I am going to highlight it. It's one of the things that we need to have in our notes. Okay, and the distance formula is used to compute distances on the coordinate plane. Do you know what the coordinate plane actually is?
The graph.
What is the coordinate plane?
The graph.
The graph. What do you mean by that? The graph. What do you mean by that? The coordinate plane. It's that thing that looks.
Oh, I got this. Ready?
Yeah, it's this part, right? It's the X and the Y. Did you realize that those are just two intersecting lines, number lines that intersect at 0, 0? Did you guys know that? Okay, great. Okay, so what I'd like you to do is I'd like to show the development of how we get the distance formula. So on your page with your rulers, okay, draw yourself as straight as possible a nice coordinate plane here. As good as you can get it. Alright, and on that coordinate plane, I'd like you to put 2 points and leave yourself some room underneath it. I'd like to call this first point A, and then up in the right-hand corner, somewhere over here, I'd like you to call that second point B. So these 2 points labeled A and B. Okay. Now we can also identify these points by using the coordinates, right? And each coordinate has an X and a Y. So what we do is we say, okay, well, I can rename this as coordinate x1, comma y1. That means I go over X amount and I go up a Y amount. The rise of a run. Very good. That means I can also do the same for this point over here. But I can't use 1s anymore, so I have to use 2s. That's the next natural number, right? X sub 2 and Y sub 2, separated by a comma. All right, great. And our goal then is to understand how this distance from A to B is defined. All right. Basically what we do is we draw a triangle and we use Pythagorean's theorem. So here's the triangle I'm going to draw for you. So let's create a right triangle. That looks like that. Okay, now let's take a look at our X part here. Our X's, okay? Our X's are X sub 2 and X sub 1. What that defines this distance right here. All the way from there to there is defined to be X sub 2 minus X sub 1. Because to get to this point, I go all the way over X sub 2. And to get to this point, I go all the way over X sub 1. So the difference of the two creates the distance of my line segment. So this represents a number, X sub 2 minus X sub 1. And the same thing works for the Y's, right? So if I just look at the Y's now, Y sub 2 and Y sub 1, that distance is represented right here. Y sub 2 minus Y sub 1. So for the x-axis, I have mapped out this portion. For the y-axis, it's all of this portion right here. Okay. Now, the Pythagorean theorem says that since you have a right triangle, then the distance, which is the part that we're looking for from A to B, the distance, so A to B line segment, is defined to be the positive square root, since we're talking about distance. Does anyone know it? Anybody remember it? It's something squared plus and then something else squared. Anybody know what I put in there? Yeah, Oscar.
X2 minus X1 plus
There it is, dude. X sub 2 minus X sub 1 and Y2 minus Y sub 1. And that right there, ladies and gentlemen, is the distance formula. What do you think about that? Easy, medium, or hard?
Hard.
Hard, okay, so that's where we're at. We're about a medium to hard? Okay.
One back. Oh, that's how you have their calculator. Use our calculators during homework and stuff.
You don't have to because you can leave your answers as a square root. The radical. All right, can we try some examples together? All right, let's try some examples together. All right, so here is the second box for you. What I'd like you to do is draw, to the best of your ability, a nice coordinate plane.
How big is that?
It needs to accompany a few spots here. So I'm going to go every 2 units. How's that? So you can go every 2 units as well, or something comparable. You do have rulers, so make the best you can make. And we're going to put a few spots, a few points on the coordinate plane. Remember, this is the x-axis, this is the y-axis. So we're going to put point A, which is at -1, comma 1. So point A is at -1, comma 1. Point B is going to be at -4, comma 3. So -4, 1, 2, 3, 1, 2, 3, 4, up 3, 1, 2, and 3. So this right here, that's going to be point B, and I'll write the coordinates down, -4, comma 3 for point B.
Make a right triangle.
Nope, and 2 more points. Point C is going to be 3, comma 2. So 1, 2, 3, comma 2. I will write those down as 3, comma 2. And then point D will be at 2, comma -1. So 2, comma -1. Point D, 2, comma -1. All right, is everybody with me so far? Yeah? Okay. So what I'd like you to do now is draw line segments to each of those. So from A to B, from A to C, from A to D. Draw line segments there. Okay, taking a look at those line segments that we have drawn, all right, which ones do you think have the same or equal distance? What does it look like from the drawing there? I'll highlight whichever ones you want me to. Which ones have the same distance? If you had to guess, what do you think? You think line segment A? You think line segment AC and line segment, what was the other one you said? Well, say it, someone say it. Wait, AC and AD.
Yeah.
We think those are the same? You think BA and AD. So here's what we're going to do. We're going to check by using the distance formula to see if those line segments are congruent. The word for the same distance is now going to be congruent. So here is how we do it. So the first thing we're going to do is we're going to take a look at line segment A to C. Okay? In order to figure out the distance from A to C, we have to figure out the points that we're going to use. So I'm going to start at A. I'm going to call this x sub 1 and y sub 1. So x sub 1 is -1 and y sub 1 is +1. Over here, x sub 2 is 3 and y sub 2 is 2. Is everyone okay how I've labeled the points? Okay, great. Now I have to use the distance formula, right? Which says this. Take the square root of, I'll move it over there. It's going to be x sub 2 minus x sub 1 all squared plus y sub 2 minus y sub 1 all squared. All right. What is the number for x sub 2? What's the number in the graph? I've labeled it over here. Does anybody see it? It's 3, right? So that's the square root of 3 minus, let's see here, what's x sub 1? -1. Now make sure you put in a -1. And we're supposed to square all of that. And then plus, what is the number for y sub 2? It's right over here. Do you see it? 2. So that's going to be 2 minus, what's the number for y sub 1? 1. And we're supposed to square that. Does everyone see the setup?
Yes.
If you get the setup, you'll probably get the problem right. Okay? So now, let's be careful here. What is 3 minus a negative 1? 4. And 4 squared is how much?
16.
So I have the square root of 16. And then I add to that, what's 2 minus 1? What's 1 squared? 1, so I get an answer of what? Square root of 17, and I can leave it like that. Okay, so that's how far it is from A to C on the coordinate plane. It's the square root of 17 units, and we can leave it just like that. And so now we have to check A to D. So I can still leave this point as x1 and y1. I'm going to label this point now x2 and y2, my new point. Okay? So let's figure out how far is it from A to D, that line segment. Again, I'm going to do the same exact thing. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. I know it's tedious, but if you write it all out, you will have a higher rate of success. Okay, that means square root of, what is the number for x sub 2? Tell me what it is. 2, yes. Minus, what's the number for x sub 1? Make sure you put a negative 1 in parentheses there. It will help you out. Plus, what's the number for y sub 2? Negative 1, very good. Minus, what's the value for y sub 1? 1, very good. And we're going to square all that. So let's simplify. How much is 2 minus the negative 1? 3. What's 3 squared? 9. Plus, what's negative 1 minus 1? Negative 2 squared? 4, very good. How much is that equal to? Square root of 13. Okay, everybody. Are these two line segments congruent? No, they are not congruent. Okay, not congruent means they're not the same. And the symbol for congruent is this right here. But for us, since they're not congruent, we're going to put a line through it. Not congruent, they're not the same. Okay, so right now, let's take another guess. We know how far AD is. We know how far AC is. Which one do you want to try now? Let's try AB, right? So right now with a partner, I would like you to correctly come up with the distance from A to B, that green highlighted part. Sit with a partner and tell me what your distance ends up being. I'll pause the... Okay, so check it out. We have now seen, right, we did the work over here. We now have seen that line segment AB, right, is congruent to which other line segment? AD, okay? So you will have to do that in your notes, in your work tonight. This is congruent. All right, are you feeling pretty good about that? Okay, are you a 1, 2, or a 3 with this lesson? Are you 1, you have no idea what's going on, 2, you're all good to go, 3, two, you only need help, right? 3, you're all good to go. All right.
He doesn't count them.
All right, it's looking pretty good. Okay, so third box. Please, at the... No, this is the third one, right?
The second one ended
After that, yeah. So, for the third box. Right, a 3-minute summary at the bottom of your notes, please.